Okay, so I think we are about to start. I'm actually waiting for a response, but I believe you can all hear me. So let's start. Good morning, everyone, again, and welcome to another brand new day, another section. I appreciate you all. And I count it a great privilege again to stand before great chemists bringing this topic, not taking it for granted. I appreciate you once more. So yesterday we did stop at factors that determines frequential discharge of ions. That's where we stopped yesterday. So we stopped at factors that determines frequential discharge of ions during electrolysis. And we did define frequential discharge of ions as the selective discharge of ions at the electrode during electrolysis under certain factors or conditions. That we have ions, and yesterday we also made it clear that ions are two types, which are the cations and the anions. And we're able to understand that the cations are positively charged ions. Positively charged ions, while the anions are negatively charged ions or ions. And these two ions, which will either be the cations or the anions, migrate to the cathode and the anode respectively. Just a minute, let me admit this person. So that the various ions migrate to the cathode and the anode respectively, such as the cations migrate to the cathode and the anions migrate to the anode. Those was that was an established fact yesterday, and we're also made to understand that the various ions, sometimes during electrolysis, we could have two or more ions migrating to the cathode or at the anode respectively. And under certain factors or conditions, only one of the ions is expected to be preferentially discharged over the other. And those factors we listed yesterday was that the first one was position of the ion in the electrochemical series. Another we also explained yesterday was concentration of the ion. And lastly, nature of the electrode. Over the years, in course of teaching, I've realized that what WAEC mostly said is this aspect. We could ask the student list the factors that determines preferential discharge of ions. Just simply tell them to list them out like this. Then also we explained the first one, which was position of the ion in the electrochemical series yesterday. We also made to understand that we have the electrochemical series for the cations and that of the anions as well. For the position of the ions in the electrochemical series, we did also say that the ions which are lower in the electrochemical series are preferentially discharged over the ones higher if other factors are constant or if other factors are negligible, so to say, such as if we have the electrochemical series, maybe I have a situation whereby I have calcium ion, and I also have an hydrogen ion. Because these two are called cations, they will obviously migrate to the cathode. And if these two get to the cathode, only one is expected to come out. And then we understood that hydrogen will be preferentially discharged over calcium because hydrogen is lower in the electrochemical series. Am I making any sense, please? Let me get feedback before I move on. Is that taken? I need response, sir. Mr. Lucky and Madam Mufuma, then if you are with me, you can respond. Let me be sure I'm not talking to myself before I continue. Response, please. And I'm still waiting for response so that we can move on. One person can just simply speak for all if you are hearing me. You are hearing me? Please, someone speak, like I said, so that we don't have to wait too long. Okay, in the absence of no response, I believe you are with me. So today we will start off from concentration of the ion in the electrolyte. Concentration of the ion in the electrolyte as another factor that determines the preferential discharge of ion in the electrochemical series. Let me use a simple example. Maybe you are teaching in a class and we know it's very rare for us to eradicate bullying in school. We try as much as possible to reduce it to the barest minimum, but there's virtually 1 or 2 or 3 scenarios whereby we have bully cases in the school. Senior ones will always want to bully the junior ones. And even students among themselves bully themselves. For example, you have SS2 students. Within those SS2 students, there are bullies among them. So take that, for example, as for concentration of the ion. If we said position of the ion in the electrochemical series, the one lower is expected to come out before the one higher. But if there's a situation whereby there's a higher concentration of the one higher than the one lower, the one with the higher concentration tends to be preferentially discharged over the one with the lower concentration, irrespective of the position. However, there's a need for you to understand that even though the concentration of the one higher is higher than that of the one lower, the one higher will come out, but then it also determines the position, how close the ions are in the electrochemical series. You should be expected to know that. Let me just go over the electrochemical series quickly. Kind of the natively quotes migrates along zinc, famous zinc, leading hydrogen, copper, mercury, and the rest. I will just simply solve it because of the board. Copper, mercury, down like that. Now, if you have a situation where I have calcium ion and hydrogen ion. And the hydrogen ion has a higher concentration. Obviously, hydrogen will come out. Then again, if the calcium ion has a higher concentration than hydrogen ion, in terms of the preferential discharge, which of them or which of the cation ions do you think will be preferentially discharged if calcium is of higher concentration than the hydrogen? Can someone respond, please? Response, please. I come again with the question. Remember, we are looking at concentration of the ion in the electrochemical. Please.
Okay.
Response, please.
You're asking if the concentration of calcium
ion
is higher than hydrogen, which of them will be preferentially discharged?
Yes, sir. Thank you, sir. Yes, that's the question, sir.
Okay.
So what do you push of the ions, sir? Do you think will be preferentially discharged?
From your electrochemical series.
Yes, sir.
Hydrogen is supposed to be preferentially discharged because it is higher from there. If you look at the distance between calcium and hydrogen, it's quite far.
Okay. Thank you very much, sir, for that wonderful explanation. That answers it. If you go by position, hydrogen is supposed to be preferentially discharged. Very correct. Also, now we will now consider the concentration. For the fact that calcium has a higher concentration than hydrogen, because of concentration of calcium is higher, it ought to be calcium being preferentially discharged, but it is not so, because the distance between calcium and hydrogen in the electrochemical series is far, like the great chemist told us, which is very correct. If you check the distance, and this is 1, 2, 3, 4, 5, 6. I have 6 cation ions before we get to calcium. So because of that, the concentration would be negligible. It will not be considered. Hence, hydrogen will still be preferentially discharged. I hope that explanation is well taken, sir, and everyone.
Yes, it's okay.
Okay. Then again, if you now consider, let's assume I have hydrogen and maybe tin or iron. Okay, let's use iron and hydrogen. If iron has a higher concentration, which of them should be preferentially discharged? Iron has a higher concentration than hydrogen.
Iron will be preferentially discharged because the distance is not that much.
Okay, thank you, sir. Very correct as well. Now, let's now look at for the anions, using this same example. I have fluorine, some nonsense can bring in oxygen. Now, I have a chloride ion and hydroxy ion. In terms of position, which of them should be preferentially discharged? Chloride ion or hydroxy ion in terms of position?
Hydroxy ion will be preferentially discharged. And teacher, you should also be calling the names of those students that are online so that they can respond to know if they are active or not.
Okay, thank you very much, sir. Thank you for that observation.
Also be calling their names.
Okay, sir. Thank you very much, sir. Thank you. Okay, so we move on. Now, hydroxy ion is preferentially discharged in terms of position. Now, when I now have a higher concentration of chloride ion as against hydroxy ion, which of them should be preferentially discharged? Is it the chloride ion or the hydroxy ion? I think I will pose this question now to Madam Ufoma. I think that's the name I'm seeing here. If you can help us out with the answer. Which of them should be preferentially discharged if you have a higher concentration of chloride ion as against hydroxy ion?
Chloride ion.
Okay, chloride ion. Thank you. So I think I can move on now. Then the third factor is nature of electrode. Nature of electrode. The nature of electrode determines also the cation or the anion that is preferentially discharged. I said something about this yesterday. I was defining terms. We said electrodes are of two types: the reactive electrode and inert electrode. Can someone give me an example of a reactive electrode based on our class yesterday? Now I'm not going to be pointing name because I might call someone and maybe you are not active, you were not in the class yesterday. So reactive electrodes. Can someone just give me an example of a reactive electrode? Now I didn't say define, just an example.
Copper.
Okay, copper. Also very correct. Copper, that's true. Then for an inert electrode. Example of an inert
Graphite, carbon, that's graphite.
Graphite. Thank you as well. So we can now say this, that a reactive electrode, those type of electrode affects or determines, or they have a selective preference for the cation or the anion that is discharged. The material that is used in producing this electrode, if it's a copper material, the copper itself will be preferentially discharged as against every other anion or the cation that is migrating to those type of electrode. In other words, a reactive electrode takes part in the chemical reaction that occurs at the electrode, while an inert electrode will not affect the ion that is discharged. So for nature of electrode, I will explain more on this when we need to look at examples of electrolysis. That way you appreciate this better. Because if you are given questions or the students are given questions, they will always specify, give the product at the cathode or at the anode during the electrolysis of maybe acidified water or maybe copper 2 tetraoxosulfate 6 using, they will specify the type of electrode, either copper electrode or a carbon electrode or a graphite electrode or platinum electrode. So that way you will now know what type of electrode was used. It will also help you to determine what was discharged. So let's move on now to examples of electrolysis. Examples of electrolysis. The first one we'll do here is electrolysis of acidified water. Electrolysis of acidified water. So for electrolysis of acidified water, please note this. Water is a non-electrolyte. Water is a non-electrolyte, but we are talking about electrolysis of acidified water. So to make the water to be acidified, it is simply, or acidified water is simply H2SO4, which is tetraoxosulfate 6 acid, dilute H2SO4. That is acidified water. So in case the students are asked, or the case the students are asking you in class, what is acidified water? Acidified water is dilute H2SO4. Am I understood, please? Is that thinking? Now, before I also move on to this explanation, let me just do this. Solute plus solvent equals to what? You can help us out with the answer. Solute plus solvent gives us what? Madam Gift, can you help us, please? Solute plus solvent gives us what? Or anybody, please. solute plus solvent.
Solute plus solvent gives you solution.
Okay. Solute plus solvent should give me solution.
Solution.
Solute, solvent gives you solution. So if we have solution, so take note of this, that solution is made up of two components, the solute and the solvent. Then I have NaCl, solid, H2O, liquid. What will I get in this equation? NaCl is sodium chloride, solid. H2O, water. Gives me what?
Sodium chloride solution.
Okay. Sodium chloride solution, which will now be aqueous.
Okay.
Yesterday. So this is just like you having your normal table salt. You put it inside water, the salt will dissolve and give you a solution. So now for you to understand this, where am I driving at is this, that we have solution to either be a concentrated solution or a dilute solution. Yeah. A solution is said to be concentrated if it has what? Who can try? A concentrated solution based on
It has less amount of water.
a solution is concentrated if it has more solute than the solvent. A concentrated solution is a solution that has more solute than solvent. For example, I have salt, dissolve it in water. If the amount of salt is higher, much higher than the water, the salt solution will be a concentrated solution. So, or let me say, I'm telling you now, concentrated solution of sodium chloride. It simply means that the sodium chloride, which is a solute, is higher than water. To let the student know this, because this will help them understand examples of electrolysis, because sometimes they will tell you, give the product at the cathode or at the anode in dilute this or in concentrated solution. So then when we have a dilute solution has more solute or more solvent rather than the solute. Just a minute. So a dilute solution has more solvent than solute. That means more water than the dissolving medium. Then also know that solute is that substance that is being dissolved in the solvent, while solvent is the dissolving medium. Can I move on?
Yeah.
Okay, thank you, sir. So, having said that, for electrolysis of acidified water, we have H2SO4, aqueous. Whenever you are talking about, you don't use concentrated acid, obviously. I know some teachers are even scared of even touching concentrated acid, maybe because of the phobia that they have. Oh, if I touch concentrated acid, it's going to burn my skin. This is my precious skin. So they don't even want to even touch it at all. The sight of it alone scare them away. So you don't even use concentrated acid for this. We always use dilute acid, especially H2SO4. Now, if I now say electrolysis of acidified water and the water is dilute H2SO4, that means I have more water than the acid. And because it is aqueous, I'm going to also have H2O, which is liquid. Then this dissociates. The tetra also sulfates will dissociate to give me what? Who can try? This will be H plus SO4, 2 minus. Then this is H plus OH minus. But I'm going to ask a simple question now. For this first one, is this equation balanced?
No.
So how do we balance this now? You simply balance it by adding 2 here.
You need to.
So that we have 2 hydrogen, 2 hydrogen. You also check here, hydrogen here is 2, 1 plus 1 give me 2, and then the water. So then we can now say ions. The ions present are, we have hydrogen ion, then please you can put this aqueous, 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 aqueous. Then SO4, which is tetraoxosulfate 6 ion, and hydroxyl ion. These are the ions present when acidified water is ionized. Any question? Then
No.
you can now write this
On my end.
as the cathode. Please, I'm using the limited version, so this class will end in the next 8 minutes. And once it goes off, we'll just take 10 minutes break and I'll be back again. So please pardon me for that. We'll come back again. Once this short done, just give yourself 10 minutes and we'll come back to continue. So as the cathode, now the hydrogen ion are cation ions. We established this part yesterday. They will migrate to the cathode, while the hydroxyl ion and the tetraoxosulfate 6 ion migrates to the anode. Now, at the cathode now, I have hydrogen ion here and also hydrogen ion. So obviously it's only hydrogen ion. So there's none of them will be considered. So what we just add here now is H plus, put your state of matter, aqueous, gives me H2 gas. Whenever hydrogen ion is the product at the cathode, it always comes out as a gaseous form, H2. Then to balance your equation, I have 2 hydrogen here. I'll put 2 hydrogen in front here. Remember yesterday, I also gave this acronym, cryo. The cathode is reduction. So what happens here now is reduction. And if you check here, oxidation number of hydrogen here, based on the charge, is 1. Here it is 0. So to balance the charge, I will add here plus 2 electrons. Any question on this, please? So the equation now is balanced. I will come back to visit this again. Can leave a line here before we go to as the anode. So now have as the anode. Now this is where we need to pay a little attention now. At the anode, I have hydroxyl ion and SO4, that is tetraoxosulfate 6 ion. Based on the fact that it is a dilute solution, water is more. And if water is more, that means the concentration of OH is higher than SO4. That also bearing in mind. Now, based on position in the electrochemical series, hydroxyl ion is preferentially discharged over this. So my ion that will migrate to the anode will be OH minus hydroxyl ion. And once your hydroxyl ion migrates to the anode, the products are always water, liquid, and oxygen gas. So, great scientists, is this equation balanced? Are you with me, please? Is it balanced for the anode? It's obviously not balanced.
It's not balanced.
That is 4 hydrogen. Altogether, also have 4 oxygen. So what I will do here is I'm going to put 4 in front of this. So let the student know, whenever hydroxyl ion is the product at the anode, the product are always these 2. Then again, the charge is not also balanced. So I will add here 4 electrons to balance the charge. I added these 4 electrons here because I have 4 charge here altogether. If there was 2, I will put 2 here. Then, to now round it up, if you check the cathode, the electron added here was 2. The electron here was 4. We must find a way to balance the charges. So I will multiply here by 2 and this by 1, so that the charges will be equal. At the end of the day, my equation at the anode still remains this. Then for the cathode now, if I say leave one line, so it now becomes 2 times 2 becomes 4H plus 4 electron, give me 2H2 gas. That is 2 volumes of hydrogen and 1 volume of oxygen. So the major product at the anode is oxygen gas, and the product at the cathode is hydrogen gas. Any question, please? So, in the absence of no question, let's now add this to it. We are so combine the 2 equations to give us the overall equation. I will come back to this very equation, but let me clean it off for now. So I'll now have overall equation.
Yes, there's a question. What happened to the tetra surface 6?
Sorry, I can't hear you.
I said, what happened to the tetra surface 6?
The tetra also surface.
Because students know that.
I'm coming there. Let's
kind of question.
You will see what happens to the tetra also surface 6 once we get this overall equation. So
okay, sir.
Cancel this 4, cancel this 4. Your overall equation now becomes 4H plus 4H minus aqueous. Give me 2 liquid, 2 gas, 2H gas. Then we have gradually rounding up this. I will come back to that your question. Then we now have this products. The cathode. Remember, the cathode was hydrogen gas, so the product is hydrogen gas. So you can just write it out in full: hydrogen gas. Then, as the anode, oxygen gas. The ratio is 2 to 1 respectively, because I have hydrogen, 2 moles of hydrogen, 1 mole of oxygen.
Mix up molecules of water. That's correct.
So now, to that your question, you will now write this at the end of the electrolysis. To help you understand that, I'm going to rewrite that ionization equation. I have H2SO4, H2, SO4, H2O, giving me H plus OH minus. Remember, this is part of the equation. Hydrogen ion. So at the end of the day, I still have my hydrogen ion and this. These two combined again, now give me SO4. So at the end of the electrolysis, the concentration of the acid increases. I think I've answered your question now.
I see.
Have I answered your question, sir?
Yes, sir, you've done that, sir.
Okay. So at the end of the electrolysis, the concentration of the acid increases. Let the student also know that the concentration increases, and then if because acid is being produced, the solution or the electrolyte has the ability to turn blue litmus paper red, because obviously it's an acid. So that is that about this particular example, electrolysis of acidified water. Then students should know the name of the